October 3rd, 2025. While 15,000 NASA scientists were sent home during the federal furlough, one of humanity's most advanced robots kept its cameras rolling on Mars. Perseverance, alone under a salmon-colored sky, captured 20 frames of something faint, slanted, and precisely where no known satellite should be. The object was moving at 60 kilometers per second, exactly along the trajectory of an interstellar visitor named 3I Atlas. And the timing could not be stranger. As the world's space agencies went silent, a smudge in the Martian night was the only proof that something alien to our solar system had just passed by. It wasn't just a glitch. The images revealed a carbon dioxide-rich glow, a halo facing the sun, and, most unnerving, a spectral trace of nickel without iron. Every pattern broke the rulebook of comets and asteroids. Is this a natural wanderer crossing our neighborhood, or is someone or something deliberately veiling what we're seeing? Tonight, the mystery of 3I Atlas deepens. The story of 3I Atlas began quietly, almost skeptically. When its first trajectory was plotted in mid-August, astronomers thought they were looking at another long-period comet. Its brightness curve fit the template. Its motion seemed steady. But then the numbers started to misbehave. The object's speed, over 60 kilometers per second relative to Mars, placed it beyond any stable solar orbit. Its eccentricity exceeded 1, confirming it wasn't bound to the sun at all. What caught scientists off guard wasn't the interstellar path. That had happened twice before with Oumuamua and Borisov. But the composition. Early infrared readings from the James Webb Space Telescope showed a coma dominated by carbon dioxide, 8 times richer than water vapor. No known comet in the inner solar system carries that ratio. Spectra from the Swift ultraviolet telescope added another riddle, faint water lines, but an unusually strong carbon monoxide band. To some, this was a quirk of measurement, perhaps a dusty surface skewing the readings. To others, it hinted at chemistry alien to our solar neighborhood. Yet the real confusion came from its appearance. The object didn't trail a tail away from the sun like a normal comet. Its light flared toward the sun, forming a fan-shaped halo. Theorists rushed to model forward scattering, charged dust, microjets, but none fully matched the data. By late September, each anomaly stacked upon another. Nickel vapor without iron, polarization inverted at a 7-degree phase angle. A trajectory hugging the ecliptic plane as if it were guided through gravitational lanes. It was becoming harder to dismiss the oddities as coincidence. If the math was right, 3I Atlas wasn't behaving like a visitor. It was acting like it knew the way. For weeks, every major observatory pointed its sensors toward 3I Atlas, and everyone came back puzzled. The James Webb Space Telescope, operating in the near-infrared, saw a coma almost entirely made of carbon dioxide. Normally, water vapor dominates a comet's spectrum. Here, the CO2 to H2O ratio was nearly 8-to-1. The simplest interpretation, surface depletion of water ice, fell apart when models showed the temperature was too low for selective outgassing. Something deeper, stranger, was happening inside the object. Meanwhile, the Swift ultraviolet telescope scanned for the familiar fingerprints of hydroxyl radicals, the daughter products of water breakdown. They were barely visible. Instead, the carbon monoxide band shone bright, suggesting a body rich in volatile ices that had formed far beyond the sun's influence, perhaps even outside any known planetary system. The Very Large Telescope in Chile added another twist. Polarimetric readings at a phase angle of 7 degrees yielded a linear polarization of negative 2.77%, statistically impossible for normal comet dust. The inversion angle, where polarization flips from negative to positive, arrived at 17 degrees instead of 21. That tiny difference implies dust grains smaller, smoother, and more reflective than anything cataloged in a century of comet studies. Then came Hubble. Its optical images revealed an asymmetrical glow stretching toward the sun, not away from it. Instead of a tail blown back by solar wind, Atlas displayed a sun-facing fan, as if scattering light forward from aligned metallic grains. The geometry didn't fit any known solar-driven process. But the most baffling discovery came from spectroscopy. The gas phase showed a persistent nickel emission line, without the corresponding iron line that always accompanies it. In every comet observed since the 1970s, Iron exceeds nickel by a factor of 10. Yet here, nickel stood alone. Laboratory experiments couldn't reproduce such separation. Both elements vaporize under ultraviolet radiation at nearly the same rate. Two schools of thought quickly formed. The first, the naturalists, argued that 3I Atlas was simply exotic, a fragment from a carbon monoxide-dominated system, its chemistry frozen in alien ratios. The second, the skeptics, asked a more unsettling question. Could this be a designed object? A relic from elsewhere? They pointed to its unnaturally stable trajectory, its low tumble rate, and the way its brightness remained constant even as its phase angle changed. Between those camps, a quiet war began. Not of ideology, but of data. Each new observation deepened the paradox. Every explanation solved one riddle only to create two more. Tonight, October 3rd, the eyes of every major mission turn once again toward Mars. Because at this moment, 3I Atlas is brushing past the red planet at a distance of only 29 million kilometers, a near miss by cosmic standards. This isn't just a headline for astronomers. It's a rare alignment of instruments scattered across two worlds. Perseverance on the surface, Mars Reconnaissance Orbiter in orbit, and a half-dozen space telescopes on Earth all have a chance to capture history. Yet the timing couldn't be worse. NASA's communication staff remain furloughed, public data feeds are frozen, and the official high-rise image sequence, expected to deliver the first resolved frames of the object, has not been released. What should have been an open scientific event has turned into a vacuum of information. Only fragments of telemetry leak through secondary channels, raw pixel arrays, timestamps, signal-to-noise ratios. Enough to confirm that something was seen, but not enough to explain it. In Pasadena, mission engineers working off the clock quietly compile those 20 Perseverance frames. Stacked, corrected for rotation, the faint slanted streak becomes visible, a perfect match for Atlas's predicted path using the JPL Horizon's ephemeris. The odds of a random artifact appearing in the same coordinates across 20 exposures are 1 in a billion, yet the agency cannot officially say a word. The rover's data stream, routed through the Deep Space Network, still falls under the same embargo that silences everything else. At the European Space Agency, Mars Express and Trace Gas Orbiter teams confirm they too observed the flyby. But their public statements end there. Data are under internal review, the press office notes. Translation: don't expect images anytime soon. For independent researchers, it feels less like caution and more like containment. And that's why tonight matters. Because if this object truly is interstellar, these hours around its Martian encounter represent the only chance to watch it up close before it races sunward and disappears behind the glare for months. Every missing frame now is a permanent hole in the record. The longer the silence lasts, the louder the speculation grows. Some scientists fear the delay will feed conspiracies about artificial origins. Others worry the opposite, that legitimate anomalies will be drowned in noise. Either way, the world is waiting, and NASA holds the key. If something extraordinary was captured above Mars tonight, only they know. At this point, every outcome is still on the table. The data are partial, the silence deafening, and the possibilities, ranging from mundane to astonishing, are dividing the global research community into three distinct camps. The first scenario, the safe, natural explanation. In this version, 3I Atlas is a rogue comet forged in the frozen outskirts of another star system. Its carbon dioxide dominance, sun-facing halo, and missing iron are quirks of chemistry, not design. Perhaps it formed in a CO2-rich nebula, its surface layered by centuries of interstellar radiation. As it entered the inner solar system, those exotic ices sublimated differently, producing optical illusions in the data. The nickel lines might come from trace inclusions near its core. If that's true, then Atlas is valuable, but not mysterious, a messenger from afar, teaching us how diverse planetary systems can be. The second scenario, the hazardous one. Here, the anomalies aren't chemical, they're physical. Some orbital analyses already show micro-deviations from the gravitational model, subtle but measurable. A dense metallic nucleus could be generating thrust through uneven outgassing, shifting its trajectory unpredictably. That might explain the perfect alignment along the ecliptic. Gravity assists disguised as coincidences. If the object's mass is as large as early estimates suggest, even a small deflection could turn it into a solar system hazard centuries from now. In this frame, Atlas is a warning, an uninvited guest whose visit reminds us how fragile orbital order really is. And then comes the third scenario, the extreme one. It starts with an uncomfortable observation. Atlas behaves as if it controls its own vector. Its path threads between Mars and Jupiter with uncanny precision. Its brightness stays constant across changing phase angles, and the spectral signatures, nickel without iron, stable polarization, could indicate structured material rather than dust. Some researchers whisper about engineered composition, an alloy designed to resist solar heating, cloaked by ice to mimic a comet. Others take it further. What if the carbon dioxide plume isn't a natural vent but exhaust? So far, no one dares put that on record. But off-camera, the idea circulates. A probe or relic drifting for millennia, only now caught in the gravity well of our star. If that were true, the implications would shake not just astronomy, but philosophy itself. The question would no longer be what Atlas is, but who sent it. Even among the skeptics, one fact remains. 7 distinct anomalies have been confirmed by at least 2 independent instruments. The probability of them occurring together by chance is infinitesimal. Whether this represents a new class of interstellar body or something unprecedented in human observation, we are standing at the edge of a discovery that will define this century. If 3I Atlas turns out to be truly extraordinary, the implications will echo far beyond a single comet sighting. The first consequence is scientific. The chemistry alone, carbon dioxide outnumbering water 8-1, isolated nickel without iron, and reversed polarization, forces astronomers to redraw their models of planetary formation. That means every assumption about how material condenses in protoplanetary disks might have to be re-examined. Was our own solar system an outlier, or have we simply never seen the full range of interstellar debris before? Then there's the political dimension. At the height of a NASA shutdown, when data pipelines and peer review networks are fractured, who controls knowledge when an event like this unfolds? If the high-resolution images from Mars orbiters remain locked in servers, the story of 3I Atlas could become the first true information crisis of modern astronomy. Does any nation have the right to withhold what may be the most important observation in human history? Or should data from deep space, by nature belonging to all humankind, be shared instantly without bureaucratic bottlenecks or national filters? Beyond policy lies philosophy. If this object proves to be natural yet unique, it expands the definition of what life-bearing ingredients might look like. CO2 dominance could mean a chemistry that thrives where we see only cold emptiness. If, however, there is even a hint of artificial structure, a fragment of intention embedded in its trajectory, the debate shifts from science to civilization. We would have to confront the possibility that intelligence has touched our solar system long before we were ready to notice. Ethically, the question deepens. How do we study a relic that may not belong to us? Would dismantling or intercepting such an object count as exploration or desecration? The international scientific community is already drafting protocols for contact, but none anticipated something drifting silently between Mars and the Sun. Whatever the truth, 3I Atlas is changing how we think about discovery itself. In the past, telescopes searched the heavens for understanding. Now they must also protect that understanding from politics, fear, and miscommunication. The real test will not be whether we can identify what Atlas is, but whether we can stay united when we finally do. Behind every silent image and every line of encrypted telemetry, there are people who haven't slept in days. Inside Jet Propulsion Laboratory, engineers who were officially furloughed still sit at their consoles, volunteering unpaid hours to keep Perseverance's data trickling through backup networks. One of them, a navigation specialist named David Finoia, cross-checked the rover's image stack by hand, frame by frame, to confirm the smudge wasn't a cosmic ray. If this turns out to be what we think it is, he wrote anonymously in a forum, we may have just photographed history by accident. Across the Atlantic, a graduate team at the European Space Operations Center runs code through the night, attempting to reconstruct 3I Atlas's orbit from the faint signals coming off Mars Express. They trade updates on Discord and encrypted group chats, their laptops covered in coffee rings and sticky notes. The work is unpaid, unofficial, but unstoppable. They know that if they can predict where the object reappears after solar conjunction, they'll give humanity one more chance to see it before it vanishes forever. Amateur astronomers join the effort. In Arizona, backyard observers stack hundreds of long-exposure images using open-source software. In Poland, a retired chemist reprocesses spectral data released by mistake through a university FTP. On Reddit and Twitter, citizen scientists publish triangulation graphs faster than institutions can deny them. For all the chaos and speculation, there's a strange unity forming. Thousands of people across continents, bound by curiosity stronger than bureaucracy. In Houston, a NASA systems engineer keeps a sticky note on her monitor that reads, "Don't let the signal die." She hasn't seen her family in 3 days. She refreshes the Deep Space Network logs every 10 minutes, watching for any ping from Perseverance that might confirm the anomaly is still visible. For these people, the mystery of 3I Atlas isn't a headline, it's a calling. They remind us that discovery is never just about data. It's about sleepless nights, about the hands behind the telescopes, about the quiet conviction that truth, no matter how strange, deserves to be known. By dawn tomorrow, the data window will close. 3I Atlas will slip behind the sun, hidden for weeks, out of sight, beyond communication, carried by inertia and mystery alike. When it reappears in December, it may be fainter, fractured, or perhaps gone entirely. Until then, all we have are fragments, a smudge in 20 rover frames, spectra with missing elements, and silence from the institutions that should be speaking loudest. But maybe that silence is its own message. Maybe it reminds us that not everything in the universe fits our expectations, or our schedules. Science is built on answers, yet progress often begins with a question left deliberately open. Atlas could be nothing more than a frozen wanderer from another sun, or it could be something far rarer, the first signal of purpose from beyond our world. Either way, it forces us to look up, to admit how little we truly know, and how extraordinary it is that we can even ask. Somewhere right now, a telescope in Chile keeps its sensors cold, waiting for the object to emerge again. A graduate student rewrites her code to chase a dot of light she may never see twice. A child in Kansas stares through a cheap backyard scope, hoping for a glimpse of history. None of them know whether they'll find anything, but all of them are part of the same story. Because whether 3I Atlas is stone, ice, or something designed, it has already changed us. It's reminded us that discovery isn't about certainty. It's about curiosity strong enough to pierce the unknown. The universe still holds its secrets tightly. And perhaps that's the point. Tomorrow, when the sun rises, the object will be gone from view. But the question it leaves behind will stay. Are we alone, or have we just witnessed the first knock on our cosmic door?